Hello everyone. Today I will be discussing the time series data stream in Elasticsearch. By the end of this video, you will understand what it is and when to leverage it. When we talk about time series, we mean data points ordered by time. This data is collected at consistent intervals. For instance, monitoring CPU usage over time. In this figure, you can see an example of tracking CPU usage across time intervals, which forms a time series dataset. Managing time series can be challenging due to its rapid growth, especially when working with high-frequency measurements. If we return back to our CPU example, taking measurements, for example, every 100 milliseconds and storing them for months, leads to a substantial amount of data points. Another challenge is storing such a large volume of data. Eventually, you will need to decide whether to archive or delete ordered data to manage storage effectively. Why use Elasticsearch for time series data? Elasticsearch efficiently handles large data volumes. It supports real-time ingestion and querying, and it enables in-depth data analysis. Check out these recommended posts for further reading on big data and analytics. Now let's examine the structure of time series data. On the x-axis, we have the timestamp, and on the y-axis, we have the data itself. It could be temperature, disk usage, CPU usage, etc. Each data point is stored as a document. You can see that each document includes a timestamp and relevant data fields. Now let's talk about index lifecycle management. ILM automates index rollover and data management. It offers many benefits like storage optimization, efficient management of index size, and automated data retention. An ILM policy has 4 phases. The hot phase, here we have active data. We frequently update the index. Then we pass to the warm phase. Here we have less frequently accessed data. The cold phase, in this case we will archive data for long-term storage. And finally we have the delete phase, where data older than a specified threshold is deleted. We will see some examples to illustrate these phases. This is what we are going to do in these upcoming slides. So now let's try to visualize the ILM phases. Suppose that we configure ILM with these rules. Here are the rollover criteria. So age is equal to 30 days, or if we hit the size equal to 50 gigabytes, we'll try to create a new index to store the data. If the age of an index reaches 90 days, we will delete it. Now let's say that we created the first index. It will implement the ILM policy. Here we have the time series data. We will start by indexing the data into this index. Now, when this index reaches 30 days, it becomes read-only, and a new index is created for incoming data. After another 30 days, this second index also becomes read-only, and a third index is generated. Finally, after an additional 30 days, the first index is deleted as it hits 90 days old, while the most recent index becomes read-only again, continuing the cycle. Here are 2 examples of querying time series data. The process is straightforward. Use the search method with the following query structure. To retrieve data between 2 specific days, use a range query and specify the 2 parameters, the greater than or equal and less than or equal values. To perform aggregations, use the aggregations parameter. And inside, specify if you want to calculate the average, the maximum value, minimum value, or whatever. So these are 2 examples that showcases how to query time series data. Now let's go to VS Code to see how to implement this. Make sure to open notebook number 23. You can see that this time we have 2 of them, because the first one we will simulate, or we will try to index the data in an infinite while loop, And in the other one, we'll try to read the data and see how to plot it and query the index. Again, if you want to read more about time series data stream, click on this link. It will take you directly to official documentation. And if you want to get access to the slides, you will find a link in the video description that will take you to GitHub. First thing we need to do is to connect to Elasticsearch. And after that, we need to define a policy. So here I'll change the policy name to number 2 because I was testing this before. And here are the phases that I was talking about in the slides. So we have a hot phase and a delete phase. When we start creating the index, we are going to store the incoming data points. So if the age of the index reaches 5 minutes, we will do a rollover. Rollover means that we will put that index in read-only mode and we'll create another index that will store the incoming data. And if the age of the index reaches 20 minutes, we will simply delete it. Here you use the ES client, you access the ILM module, and here you have the put lifecycle method. You need to give it a name and the policy dictionary. When you do this, you should get a knowledge true, which means that you were able to create the ILM policy. After that, immediately we need to create the index template. Again, you give it a name. Here you have the index patterns. I told you that when we start, we create the first index. And then when the index becomes old, we will create another one. You need to have a prefix. And then this asterisk will be replaced by the number of the index. We'll see this later. But you have to specify this in the index patterns parameter. After that, you need to enable data stream because we are using time series data stream. And here is the template. Let me start with the mappings because that we have seen this before. Basically, here we have 3 fields: the timestamp, the CPU usage, and CPU name. For CPU usage, you can see this is a float value. And here we have specified another parameter, which is time series metric equals gauge. This means that we will get variable values. And for CPU name, you need to have time series dimension equal true because you need to have at least one keyword per field in our index. If you don't do this, you will get an error while trying to create the index template. So this is the mapping. Now we need to change some settings for the index. First, the mode should be time series because we are working with time series data. And here we are going to implement the ILM policy that we created before. So let's try to create this. Okay, so this is giving me some errors because I think I already have this before. Okay, I changed the name and index patterns to CPU example template instead of CPU usage data because I was already testing this and I created an index template with CPU usage data. So we tried to match that pattern and this is why I was getting that error. Now we can start reading data from the CPU and indexing it to the index. Here we are using the psutil package. It allows us to get the CPU percentage, and here you have the interval. So here, each 100 milliseconds, we will try to read the CPU percentage and index that to the first index. So here we have the timestamp. We are using the datetime package to get that. Here CPU usage, as I told you, we are going to use psutil. And finally, this is the CPU that I have on my PC, so I hard-coded this value. But you can see that each data point is a document. So here, I think I need to change, I need to change the index alias to CPU example template. Now, let me run this. Okay, so this is giving me some errors. So I'll just change it to UTC now. So now it is working. We are getting the data from the CPU and we are indexing the documents each 100 milliseconds. To verify if this is correct, let's go to the second notebook. Again, we need to connect to Elasticsearch. Here, let me get the index name and put it here. And as you can see, we have 213. If I keep running this, you can see that the count keeps increasing because the while loop is running forever. This is great. Now, let's try to get everything. So we are using the search method, and again I need to change the index, and here I'll try to get everything, so by setting the size to a very high value. Now let me show you how to plot the data. You can see that we are using the matplotlib library. Here we are getting the CPU usage and timestamp values, and basically we are using matplotlib to plot data. You can see that here is the timestamp axis and here is the CPU usage percentage. Now, if you want to compute aggregations, it's simple. Sorry, I need to change the index to this one. And this gives us the average CPU usage, which is 34% in this case. First, you specify the index, and inside the body, you use the aggregations method. And inside here, we computed the average in this case. But if you want to compute the maximum value, you can do that. Let me just change the index to this one. And this is the maximum value. Let's see if that's correct. Yeah, so here, I think I need to rerun this cell because now we have more data points. And yeah, you can see that this is the maximum value, which is 81%. Now let's monitor the index lifecycle. This is very important because this will demonstrate how the policy phases works. So here, just to make sure that everything is good, you can see that we have the CPU usage velocity policy v2. This is what we created right now. And currently we have just one CPU. You can see that, oh, sorry, we have just one index. So this is the prefix CPU example template, and ElasticSearch added some string just to identify this index. Okay, so here is the name, here is the policy that we are using, CPU usage policy v2, etc. So here you have a lot of information, and here we have another one. Yeah, this is the one that I used before recording this video. So CPU usage policy. So I don't want to look at this. I just want to look at the first one because this is what we created. Great. So if you see something, this means everything went well because we already enabled data stream here by adding this. If you don't add this, you will not get an output here. Make sure that you get something here before running the upcoming cells, because that is very important. Now, again, here I need to change this to V2. And as you can see, this gives us the life cycle of the policy. So far, we only have just one index. Now, if I take this index and paste it here, you will see that we can monitor the life cycle of one index, of a specific index. You can see that here is the age, it's 4.27 minutes. It was time since index creation is 4.27. If I keep running this, you can see that the age value changes. And now, in theory, if this hits 5 minutes, we should do a rollover and create a new index. But by default, ILM checks every 10 minutes for indices that meet policy criteria. This means even if the index reaches 5 minutes, we will not create a new index. We should wait 10 minutes for the ILM policy to do the periodic checking. If the age of the index reaches 10 minutes, we should see that we will have the first index. It will be in read-only mode, and we will have another index that will store the incoming data. So I will wait for 5 minutes and then I will show you how this looks like. I really haven't checked if we can change this default value. Maybe we can, but because I didn't find it, so I'll just wait for 10 minutes and then see what we will get. Okay, I am back. I've waited for almost 10 minutes and you can see that I rerun this cell and now we have another index that was created. Now let me go back to the first index and try to examine it closely. You can see that the age resets. Here the action is complete. Let's compare it to the second index. You can see that the second index is in rollover mode. The age is the same. Phase is hot. So yeah, you get the idea. Now, if we wait for 10 minutes, this index will go to read-only mode and we will create a third index that will store the incoming data. Now, if I go to the first index, you can see that, and if I go back to the first notebook, remember, the delete phase will execute once the age of the index is older than 20 minutes. Now, you can see that currently we have two indices. The first one will get deleted automatically when it reaches 20 minutes. So I'll wait again and see what we will get. Okay, so I have replaced the index name with this so that I can get the explanation for all indices. And now if I click on scrollable elements, you can see that we still have two indices, but now for the first one, the action switched to delete. So this one should be deleted very soon. This one is still on rollover. It's a little bit tricky because I don't know what is happening. I was waiting for a lot of time. So now the age of the index is close to 40 minutes. We still have not been able to delete it, even though we specified that the minimum age should be 20 minutes. The second one, again, the age is 39 minutes, but we are still on rollover, so we didn't create the third index. So yeah, even though we have specified the criteria for each phase, Elasticsearch still does not respond immediately. I'm really not sure why, but I'll wait for more minutes and then see what would happen. Okay, so as you can see now, things have changed. The first index was deleted, and now we have a third index that was created. Let's run this cell to get an explanation of what is happening. Again, click on scrollable elements and let's see. So now the first index, as you can see, it no longer exists, so it was deleted. But now this one went from rollover to complete. This means that the next phase will be delete. Now the third one is still on rollover. So this is what I was talking about in the slides, precisely in this slide. So the first index was deleted and the second one is in read mode, and we created a new one. And the process will keep repeating. The problem that I have is that this does not follow the criteria that we have specified. So sometimes this will work. You will see that the phases will change in 10 minutes, sometimes 20, 30. I really don't know what is happening under the hood, and I didn't do a lot of research into this. But I just wanted to show you that the phases are working. And now let me just go back to show you that we still have a lot of data points. So here you can see that the first index did have a lot of data. Because now it was deleted, we went from 20,000 to 30,000 points. This confirms that the index was deleted successfully. We arrived at the end of this video, and it was a little bit hard because ILM policies are not that easy to test, so they need a lot of time to make sure that they are working. But I hope that you enjoyed the video, you found it informative, and please, before leaving the video, leave a like and subscribe to the channel. See you next time.